Okay, Tejas, you have seen this question, and we were doing this question in the previous class in your batch. So you are going to tell me, okay, step by step. Because here, quick, I have given the hints and everything, which is from this question. So I don't know everyone have understood or not. So again, I am taking the same question. See, this question I have taken in the previous class. Yes, Arhan, Sarah, Hanan, Anam, the student who just belong to this batch. I have taken already. I have taken this question in the previous class. I was explaining it, but somehow I realized that since I have not written the explanation, you all got ended up getting confused. Okay. No, Tejas, I cannot hear you.
Ma'am, can you hear me?
Yes, now I can.
Okay, so
Just a moment, let me write the data which is given along with the question. So here it is given that ABC and DPC are isosceles triangles. And we have to show that, that's it. We have to show that triangle ABD is congruent with triangle ACD. First, this is the first part. And the next part is triangle ABP is congruent with triangle ACP. Yes, Tejas. What to do over here? ABC is an isosceles triangle. ABC. Can we say that this two sides must be equal since it's an isosceles triangle? Can we say?
ma'am, can you hear me?
Yes, now I can hear you.
Okay.
Okay, so we will be taking the triangle ABD and ACD. Triangle ABD and triangle ACD we will be taking. And can we say AB over here is equals to AC over there? Why? Because the complete triangle ABC is an isosceles triangle.
Yes.
Now,
Ma'am,
can we say, yes, Tejas, what can we
ma'am,
say?
we can say DB is equal to DC.
We can say DP is equals to DC. Why?
Given.
Given already, because triangle DBC is an isosceles triangle.
अभी ज्वाइन करिए
Who is there?
अभी
Who is there? From where this noise is coming?
Ma'am, AD is common.
It is the common side. And hence these two triangles are congruent with each other. Yes or no?
Yes, ma'am. By SSS.
By SSS congruency. Okay. Now the next part. We also have to prove that ABP and ACP. ABP, ACP. ABP, ACP. Where is P? Here is P. Okay. ABP and ACP, these two are.
Ma'am, we can use the first questions.
In triangle ABP and triangle ACP. The second part we are trying to do. ACP. Yes. We can see here also that side AB and side AC are same.
Yes.
Isosceles triangle, right? What else?
Ma'am, angle BAP is equal to angle CAP.
Yes. Angle BAP is equals to angle CAP. Why? Because
CP.
just now we have proved. Yes, just now we have proved that triangle ABD is congruent with ACD. So by CPCT we can write it. Okay.
Ma'am, AP is
And
the common
AP
side.
is common.
Yes, AP is common.
So by SAS.
So by SAS criteria, this two. Just a second. Now there is one more part over here. That is the third part says that AP bisect angle A as well as angle B bisect angle A as well as angle D. That's what we have to prove now. How will be doing so? Who joined just now?
Ma'am, me, Irshad.
Irshad. Okay. Yes, Irshad, still I have not started. One question we were doing from triangle. Wait, just after finishing this one, we'll be starting. Oh yeah, this part we have not done in that batch also. So the third part we have to prove over here that AP bisect angle A. See this question, Irshad, you can also focus over here. This question is the same question which we were discussing in our batch. Okay, and we have already proved the first part in our batch also and the second part in our batch also, right?
Yes,
Yes, ma'am.
The third part we have not proved, so let's try proving it. Okay. Third part is to prove that AP bisect angle A as well as angle D. Yes, from my actual batch, this batch, Arhan, Sarah, Saad, Hanan, Anam. How to prove it?
Ma'am, angle PAD equals to angle CAD. So AD bisects angle A and AB bisects angle.
Angle BAD is equals to angle CAD. By CPCT, we already know because we have proved this two triangle congruent. So yes, angle A is getting bisected. Hence AP bisect angle A.
and AD bisects angle B.
How to prove that AP bisect angle D also? Angle D also. This part of D and this part of D. Anyhow, we have to prove it same. Then only we can say angle D is also getting bisected by the same AP. Getting it?
Ma'am, we can take triangle DBP and triangle CDP.
Yes, is it possible? Is it possible to prove this two triangle congruent?
Yes.
How? We know that DB over here is equals to DC over there. Isosceles triangle. It was given this to our isosceles triangle. So yeah,
Ma'am,
so
BP is equal to CP.
BP is equals to CP. Do we know that? From where? From yeah, from here, BPCP. Can you see just now we have proved something from there? BPCP are same. Can you see the cursor? Cursor. Everyone can see the cursor. BPCP are
Yes,
equal.
ma'am.
Okay, so
Yes, ma'am.
BPCP are equal. Why?
BP is
Because just now we have proved ABP is congruent with AC. And what else?
DP is common.
So side congruency criteria. These two triangle are congruent and hence and hence this D is getting bisected. That is D over here. This angle and this angle are same. That means angle D is getting bisected by the line AB. Perfect. What is the next?
Ma'am,
The
fourth.
fourth part is also here. Part 4 is also here. AP is perpendicular bisector. Part 4 is AP is perpendicular bisector.
Ma'am, angle ABP is equal to sorry, triangle ABP is equal to triangle ACP. Proved out.
We have to show that this part AP is perpendicular bisector of BC. Okay, so to prove what? To prove that AP is perpendicular bisector of BC. Yes, what you said?
Ma'am, we can take triangle ABP is equal to angle ACB. That is proved above.
Angle or triangle?
Triangle.
Two are congruent, already proved. These two are congruent. What we have to show, AP is the perpendicular also 90 degree over here. That's what we have to prove. So is it possible to prove this to 90 degree? Yeah.
Yes, ma'am.
Yes, we can say that. We can say that angle APB plus angle APC is making
Is
a
equal
linear
to
pair.
180. Yes, ma'am.
These two are making a linear pair. Okay,
Yes.
and these two are equal with each other. Okay, we can say that APB is equals to APC from here, from this already proved part. That is equals to X, let's say. Okay, so ABB, this is also X, this is also X, is equals to 180. Then X will be 90 degree, right?
Yes, ma'am.
So hence AP is perpendicular. We have proved that. And bisector of BC, yeah. From here we are also getting BP and CP are same. Yes, we are done. And also BP and CP are equal. So AP is perpendicular also. AP is bisecting the side BC also. Therefore AP is perpendicular bisector
Of BC.
of BC. Is it clear to everyone?
Yes, ma'am.
Okay, now we will be
Yes, ma'am.
starting the revision. There are few more questions after this. At first you try it. Okay, if you will not be able to do, then we will be taking it over here. Okay, now let's continue with our revision of number system. Yes, to whom I said will be there are few questions which you have to try. Arhan, Sara, Samya is not there. Who is there? Anam, Hanan. Okay, you have to try the next 2 3 questions, and you have to let me know whether you are able to do it by yourself. Okay, Saad. If you can't, then I'll be taking it. Let's continue. Okay, no worries. Irshad. Let's continue. So now we'll be doing the discussion on number system. Okay, concept I'm not going to explain here. Basically, this is the revision class for number system. So we'll be taking few questions which is exactly requires discussion explanation. So let me take it out. Suppose we are having 256. Okay, and it is like this. Let's solve it. Ma'am, I have maths annual exam 6 October. It's my last exam. Oh, your annual exam is in October. You are having
No, ma'am.
like
My first exam is on. Uh, Let me check. My first exam is on 26th September.
okay. So this is your final exam.
No, ma'am. I'm sorry, half yearly.
Okay, yeah, it is a half year. Of course, in our curriculum, CBSE curriculum, the exam pattern is like this. This is the time where they give the half yearly exam, and towards like I think January, February, there is a annual exam, right?
Yes, ma'am.
Please do it now by using the law of exponent. Please do it, everyone.
Ma'am, should I also do this?
Ma'am,
Yes,
would the answer
everyone.
be 2 6 power minus 1 by 4?
6 to the power minus 1 by 4. Not sure. We'll be checking it. Uh, Anam, you responded. Who responded?
I did, ma'am.
Okay, Ifra, you have done. Okay, yes, everyone should do this question. This is from here law of exponent, which we have already discussed in the previous class that we need to use over here.
Yeah.
Yes, Ifra, just give me a moment. Let everyone try. We'll be discussing it.
Ma'am, my answer is coming out to be 4.
4, Anam, you said, right?
Yes, ma'am.
You have turned off your video, everyone. Why? Anam, your video is on. Arhan, Hanan, Ifra, Ifra, you have to turn on your video. Everyone, not only you. Shad, Irshad.
Ma'am,
Yes, perfect.
Ma'am,
Ifra,
I'm getting 4.
okay. Let's check it. Let's check. If we have to write this 256 in exponent form, how will we writing it? Anand, if we have to write this 256 in exponent form, I don't know how to write it. Let's do the factorization. 2 1 times 2, 2 times 4, 8 times 16, 2 6 times 12, 2 4 times 8. Now it seems like we know. Okay, 2. Still, if you want to continue, you can continue. 2 3 times 6, 2 times. Okay, 32 means 2 to the power 5. If you know, you can stop here. If you don't know, you can still continue the prime factorization. So we are getting that it is nothing but 2 to the power 5, 6, 7, 8. 2 to the power 8. 256 means 2 to the power 8. How we got it? We did the factorization, prime factorization, and then we got it. Okay, and then whatever is there, we will be writing it as it is, as it is. So minus 1 by 4 over here, then the power 2 is there, that also will be continuing as it is. Okay, now let's continue from here. First, whatever number you can see, you have to write it in exponent form, then only you will be able to use the exponent rule. Okay, so 2 to the power 8 is there, and then power minus 1 by 2 is there. Let's open it. We know there is a property. Okay, I think this one I have missed in the last class. There is a rule, a to the power m to the power n. If two different powers are there, we have to do the multiplication of powers. Yes, really sorry for that. This rule I have not taken in the last class. A to the power m and then power n is there. That means we have to do the multiplication of the powers like this. Okay. So here we will be doing the multiplication of power one by one. One by one. So it will be 8 into, if you will multiply minus 1 by 2 like this, and the remaining exponent, just to avoid the confusion, you can keep it as it is for now. Okay, so let's do the simplification. Let's do the simplification. The fractional multiplication we are having 2 4 times 8. So what are we having? We are having 2 to the power minus 4 now. Check it. Check it. 4 into minus 1 minus 4. And then one more power is there, that is minus 1 by 4, which we can do the multiplication over here. Okay. Still power 2 is there. It's okay. So we will be multiplying it minus 4 with minus 1 by 4. The fractional multiplication we have to do, and still we are having power 2 over. 4 4 gone, minus minus plus, we are having just 2. Minus minus plus, just 2 to the power 1 we will be having, and then one power is still power 2 is there. Can you see it? That means the answer is 4.
Yes, ma'am.
Everyone, are you understanding?
Yes, ma'am.
Yes, ma'am.
Okay, so this is how we'll be solving such question. If suppose, if a is equals to 1, b is equals to 2, then a to the power b plus b to the power a power minus 1 will be, yes, it will be. Please take your time and do it.
ma'am, 1 upon 3.
1 upon 6. 6 you said?
3.
3. 3 you are saying, right?
Yes, ma'am.
Okay, we'll be checking it. Yes, rest of the student, what are you getting?
Ma'am, my answer is also the same.
Okay, it's same.
And mine also is same.
Is it same? Let's
Ma'am,
do
same
it.
answer.
Same. Everyone
Ma'am,
is
same
getting
answer.
A to the power b, that means 1 to the power 2. And b to the power a, that means 2 to the power 1. Okay, and that's minus 1. That means 1 plus 2 and power minus 1. That means 3 to the power minus 1 can be written as 1 by 3. Perfect. Let's do this one. If x is equals to 7 plus 4 root 3 and xy is equals to 1, then 1 by x plus 1 by y will be
Ma'am, 14.
14. Yes, rest of the student. Let's do it. Let's do it. 1 by x plus 1 by y, if we will take out the LCM, if we will take out the LCM, yeah. If we will take out the LCM will be 1 by x plus 1 by y. LCM will be
XY.
xy. And in numerator, what are we going to have?
Y plus X.
Y plus x. Everyone getting it? How we are writing this part?
Yes, ma'am.
Okay. Now xy we know that is 1. X we know that is 7 plus 4 root 3. But y we don't. How we'll be taking out y? Is it possible if x is this one and xy is 1? Can you see if we will substitute x value over here, then y we will be getting? Can you see it? Can you see it?
Ma'am, Y will be 1 upon X.
Yes. Y is nothing but, from here we can write y is nothing but 1 upon x. And what is x? We know that. This is y, right? As it is, if you want, you can use y, or the rationalized form you can use. That will be simpler to use. The rationalized form. Okay, can you see what is y? Everyone getting it? What is y? Okay, and the rationalized
Yes,
form
ma'am.
for y is 1 by 7 plus 4 root 3. But we can also write 1 by 7 plus 4 root 3 as the rationalized form. That is, we will be doing the multiplication. We will be doing the multiplication with, if a plus b structure is there, then a minus b, like that. Everyone getting it?
Yes, ma'am.
Okay, and hence we are going to get 7 minus 4 root 3 in the numerator. But in denominator, it will take, we can use the identity a square minus b square. That means 7 minus 4 root 3 will be there in the numerator. But in denominator, 7 square is 49. And who will say? What is the square of 4 root 3?
48.
48. Let's check it. 4 root 3 whole square means 4 root 3 into 4 root 3.
48.
4 into 4. 4 into 4, we can multiply the number because all are just in multiplication with each other. So 4 times 16 and root 3 into root 3 is just 3. Can you see it is 48? So in denominator 49 minus 48 is there. That means 7 minus 4 root 3 by 1 is there. This is the y value. Y value, whatever we were having, that one and this one is the same thing. It's the just the different, like it looks like different, but actually it is same. Okay, we have just done little bit of arrangement and all, but actually it is same. Why it's same? 1 by 7 minus 4 root 3 and 7, 1 by 7 plus 4 root 3 and 7 minus 4 root 3. Is it same? These two are same. How I am saying these two are same? Yes, these two are same. Here we have done the multiplication by same term in the numerator and denominator, and then we got this version. Here if you will multiply in the numerator and denominator, in the other side, if you will multiply in the numerator and denominator with 7 plus 4 root 3, you will be getting the same result. You will be getting the same result. Check it. And when we are doing the multiplication or division by a same number, same term in numerator and denominator of any fraction, that means we are not changing anything. It's just equivalent fraction. If we are having, if we are having 24 by 36 and you are writing it as 2 1 times 2 2 times 4, 2 1 times 2 2 8 times 16, you are writing it as a 12 by 18, that means you are not changing anything. 24 by 36 and 12 by 18 is the same equivalent fraction. What we did, we have just done the division with 2 in the numerator and in the denominator, and hence we got 12 in the numerator and 18 in the denominator. 24 by 36 and 12 by 18 is equivalent fraction. It's same. Similarly, 1 by 7 plus 4 root 3 and 7 minus 4 root 3 by 1. It's the same equivalent fraction. Getting it?
Yes, ma'am.
Okay, so y value was 1 by 7 plus 4 root 3, but we are using our concept of rationalization, and 7 minus 4 root 3 is the another version of y. We will be using it over here because that will be easier to do the simplification after that. If you will be writing 1 by 7 plus 4 root 3 at the place of y, still we can do the calculation, but that will be a little bit tricky. Okay, I'm showing you. This is what we are getting. Okay, 7 7 14, 4 root 3 4 root 3 gone 0. So 14. Yes, Sarah, you said no.
Ma'am,
You
I
said
did.
14. Anam, you said
Yes, ma'am.
yes, 14 is the perfect correct. Okay, we will be getting 14. And what if you have taken y value as it is? You didn't like think about doing the rationalization, and still we will be getting the answer. But that will be so much huge calculation will be there. Let me show you. We are having y plus x in the numerator and xy in the denominator. Now only we realize that y is 1 by 7 plus 4 root 3 and x is given, that is 7 plus 4 root 3. Okay, let's continue. 1 here, at first we'll be taking the LCM for the numerators part, because in denominator 1 is there, so even if you are not writing 1, that is okay. So now we have to solve this part only. So LCM we will be finding. What will be the LCM? Who will say what will be the LCM over there? What will be the LCM? Is it 7 plus 4 root 3? Is it so?
Yes, ma'am.
And the numerator will be as it is, the first one. The second one, since the denominator is different, okay, and LCM we are saying is this, we have to change the numerator. Okay, by what we will be doing the multiplication with this, whatever is there in the LCM part, that we will be doing the multiplication in the numerators part. Okay, so we are going to get this, and still you have to do the rationalization. Still you have to do the rationalization, then only you will be getting 14, this 14. Okay, let's do it. Let's see. In numerator, 7 plus 4 root 3 was already there. In numerator, 7 plus 4 root 3 was already there. This was already there. This was already there. And we are doing the multiplication with one more 7 plus 4 root 3. Okay. Now this became 7 plus 4 root 3 whole square. And this is 1. Can you see huge calculation?
Yes, ma'am.
Okay. We avoided this scenario when we did it like that. If you will expand it again, you will rationalize it, you will be getting the answer as a 14 only. But after so much of calculation and wasting our time. Okay, so if any time you are saying that I was lacking time during the exam, I knew few questions but was not having enough time, that means you have given extra time to few questions where it was not required. Okay, and hence there will be shortage of time during the exam. So this approach never ever we will use this approach. Let's continue. If 10 to the power x is equals to 64, then 10 to the power x by 2 plus 1 will be what? Let's discuss it. Can we write this 10 to the power x by 2 as a 10 to the power? Okay. First, let me confirm this x by 2 and 1 all are there in the exponent part or what? Yeah. This all are the exponents. It is like this 10 to the power x by 2 plus 1. Okay. So we can write it. We can write it as a 10 to the power x by 2 into 10 to the power 1. Can we write it like this? Can we?
Yes, ma'am.
Yes, because a to the power m into a to the power n is a to the power m plus n. So if m plus n structure is there, then we can break it like this, right? And this one, can we write it as a 10 to the power x? And that's power 1 by 2. Can we?
Yes,
Into
ma'am.
10. 10 to the power x is 64. 64 to the power 1 by 2 into 10. What will be the square root of 64?
I'm 8.
See, you should know that 1 by 2 power means square root. So 8 into 10. Result is 80. Is it making sense to you all? How we are using the law of exponent? Can you see it, everyone?
Yes, ma'am.
So this is how we'll be
Yes,
solving
ma'am.
this question. Okay. Now there will be few classes which will completely be based on the revision of number system. Then we'll be doing the revision of polynomial.